Yeah, like.
So let's move on if there's no question. And the next thing that I want us to talk about is this enthalpy that we're talking about here. Enthalpy H. This enthalpy that we're talking about here, I want us to break it down into actual changes, because I have said that energy changes are the changes that occur in energy, whether energy is lost to the environment or absorbed from the environment, from the environment, whether we have chemical changes or physical processes. So I want us to break them down and see what kind of processes are these that we are talking about. And I'm going to look at a few, actually just list physical processes, and these ones include melting. Now we know that melting is the process in which a solid changes into a liquid when heated. Now the enthalpy, or the energy that is involved when something is melting, is referred to as enthalpy of fusion. Enthalpy of fusion. Now, or heat of fusion.
Latent,
yeah. I want to heat of fusion. Now, if you just had a piece of, say, ice that you are heating and you wanted to change into a liquid, then you would call that latent heat of fusion. But if at all you have 1 mole of ice that you want to heat and you want that to change into liquid water, then you're going to call that molar heat of fusion. So in most of these questions, we're going to be dealing with the molar thing, because of course you people are from Form 3, and I know that you have dealt with the mole, so you know what this is all about. Whenever I talk about molar something, I'm talking about that something in relation to a quantity that is equivalent to 1 mole of that thing. So molar heat of fusion is the heat change, or the enthalpy change that is involved when 1 mole of a solid changes into a liquid without change of temperature, or at a constant temperature. That is melting. Another physical process is evaporation, or vaporization actually. Vaporization. And of course the definition is almost the same, only that we change a few terms. So we have latent heat of vaporization, and we have molar heat of vaporization. So molar heat of vaporization. And this is the enthalpy change when 1 mole of a liquid changes into a gas at a constant temperature or without change of temperature. That is evaporation of water into steam or any other liquid, spirit, whatever you can heat, a liquid changing into a gas or steam. Now note that the amount, or rather if at all, the molar enthalpy, the molar heat of fusion of ice, if that is 4320 kilojoules, this is the energy that would be absorbed, for example, when 1 mole of ice changes into water. Now the same value would be released if the water was now freezing back into ice. If this was positive when we were heating, or rather when the substance was melting, it will be negative when the substance is freezing back to the solid form, but the value will be the same. So only the sign will be changing. So the molar enthalpy of fusion is the same whether we are moving towards the melting or towards the freezing. Vaporization. The molar enthalpy of vaporization is going to be the same figure, whether something is changing into a gas or whether the gas is condensing back into a liquid. So those are examples of some of the most common processes. Of course, we have sublimation, we have deposition, we have all those examples of chemical processes. You have a question?
10 minutes
remaining. It's okay, we just cut it and then I'll come back. Now, chemical processes, these ones include like the reaction that I have been using so many times, neutralization, a reaction between an acid and a base. And that gives us what we call molar enthalpy of neutralization. And this will be delta H neut. When we're talking about latent heat, somebody may write H, delta H, and then put a subscript down here denoting what is happening. If it is evaporation, if it is fusion, etc. A subscript, a small name or word below the H to denote what the enthalpy is. So this is molar enthalpy of neutralization, and by definition, the molar enthalpy of neutralization is the enthalpy change involved when 1 mole of hydrogen ions from an acid is displaced by a base. Or you can define this one as the enthalpy change involved when an acid reacts with a base to form 1 mole of water. So that is molar enthalpy of neutralization. We have another one called molar enthalpy of combustion. So that is neutralization, combustion. And the molar enthalpy of combustion is the amount of heat energy, enthalpy change involved when 1 mole of a substance burns completely in oxygen. I hope the students are getting these things. On Zoom, are they able to follow that?
Yeah, they're following.
Okay. All right. So molar enthalpy of combustion is the enthalpy change when 1 mole of a substance burns completely in oxygen. Another one is molar enthalpy of solution. Molar enthalpy of solution. And that is the enthalpy change when 1 mole of a substance dissolves in a solvent to form an infinitely dilute solution. So it could be just sodium chloride put in water. So 1 mole of sodium chloride put in so much water, that is our solvent, so that the solution formed is infinitely dilute. It is completely dilute. So that is molar enthalpy of solution. There is molar enthalpy of displacement, and that is the enthalpy change. I hope our camera is not shaking so much. All right. So molar enthalpy of displacement, and that is the enthalpy change involved when 1 mole of a substance is displaced from its solution. It could be, for example, copper sulfate solution, and then you introduce zinc, the solid, so that the products are zinc sulfate plus copper solid. So the copper ions that were in this solution have been displaced. They have been kicked out. So if at all we are talking about 1 mole of copper ions displaced, then that is molar enthalpy of displacement. Another enthalpy is we could have so many of them, so I may not go through all of them, but I know that you are getting the hang of it. You understand what I'm talking about here. So anytime we talk about molar enthalpy, we are talking about the energy change involving 1 mole of something. So if it's combustion, the molar enthalpy or the energy change when 1 mole of a substance is burned. Molar enthalpy of neutralization, the enthalpy change when 1 mole of an acid is neutralized by a base. 1 mole of hydrogen ions displaced or neutralized by a base. Molar enthalpy of solution, the enthalpy change when 1 mole of a solute dissolves in a solvent to form an infinitely dilute solution. Molar enthalpy of which one did I leave out? In fusion, the enthalpy change when 1 mole of a solid is heated so that it melts or changes into a liquid without change of temperature, at the same temperature. Vaporization, the enthalpy change involved when 1 mole of a liquid changes into a gas without change of temperature. So those are some of the enthalpy changes, the energy changes the definitions. Those are some of the processes that we're going to concern ourselves with. And Mr. Mushera, unless you have a question, I would like us to stop there so that then we continue in a few minutes and do some questions involving calculation of enthalpy changes.